Hello everyone, welcome to my channel. Today's topic is extremely interesting and intriguing. The topic is artificial intelligence paradox. So what is this artificial intelligence paradox? Before we answer that question and go into the details, let's break up the topic and study the individual terms therein. So the first term to understand is paradox. What is a paradox? Well, a paradox is essentially two contradicting points of view, two conflicting thoughts, and two opposite conclusions. That constitutes a paradox. Paradoxes are common in nature, in life, and in the way we think. And why it is common? Because the human brain puts together a lot of information, and while processing all of this information, it will come about many conflicting views. And based on these conflicting views, the essence of human intelligence picks, depending on the situation and the goal, it picks the most appropriate point of view in order to proceed with a particular decision or to make sense of a particular perception. That is inherent in human intelligence. However, for artificial intelligence systems, it is not the case. And therefore, we are dealing with AI paradoxes today. As researchers develop artificial intelligence, they are coming about to experience the paradoxes in the process of developing AI solutions and technologies. So, now going back to defining the term AI paradox. So, we understood what is a paradox. Now, what is artificial intelligence? Well, who coined the word artificial intelligence? Artificial intelligence was coined by John McCarthy in 1955, and he presented the term AI in 1956 in the Dartmouth Conference. So he was an American computer scientist and often called as the father of AI or artificial intelligence. So, in order to understand what is artificial intelligence, let's delve into the core of what is intelligence. What is the essence of intelligence? So, in order to understand what is intelligence, we must understand what is called as the data value chain. Data value chain is nothing but the process of converting data into information, information into knowledge, knowledge into insight, and insight into wisdom. This is the data value chain. And when we say a human being is intelligent, what we mean by that is that individual has the ability to demonstrate appropriate application of knowledge and insight, which is called as wisdom, in every single situation, no matter what the challenge, no matter what the problem or issue that he or she is facing. That is an intelligent human being. Now, when it comes to machines, specifically when it comes to computing systems and computers, this entire process of converting data to information, information to knowledge, knowledge to insights, and insights to wisdom is not automatic. Computers have to be programmed. It is not inherent that they are born with intelligence. However, human beings can be born with inherent intelligence, with degrees of intelligence, of course, relative to each other, but they are born with inherent intelligence, and that inherent intelligence gives a 1-year-old child or a toddler the ability to recognize instinctively, intuitively images, objects, its mother and father, its relatives. The child is able to recognize voice, is able to smell, is able to process language, is able to speak, is able to touch. It's able to do a lot of things which is taught to the child intuitively. And who teaches the child? The environment, the parents, the environment in the home, the environment in the preschool. All of this is what teaches the child. The child is responding to the stimuli in the environment and in a natural manner learning how to do things. And in that process, it is learning to recognize the world around it, and the child is labeling within its brain, the child is labeling the various objects and human beings it recognizes every single day. And that's how the child is learning. And that's how human intelligence is demonstrating itself and manifesting itself. And the human brain grows more and more intelligent as the child grows, as the neurons make more connections with the natural growth of the child. And that is how, in that process of time, the data value chain becomes stronger and stronger as the human child brains evolves over time and life experience. And nature has instilled this in the evolution of the human brain over 1 billion years, they say. Over 1 billion years. And human beings today and computer scientists today are trying to mimic what nature took 1 billion years to achieve in the way of human intelligence by evolving the best possible processing machine known in the universe, the human brain. And that is the ultimate goal of every AI project, or the final frontier of the AI endeavor. So before we go to the level of superintelligence and achieve synergy with the human brain and human level of intelligence, there are many steps to be accomplished. And that is why we have to deal with a lot of paradoxes and resolve these paradoxes in order to grow AI and AI's implications and positive advantages towards betterment of the people and the planet. So that is what is the data value chain. And as we understood, the human brain, which evolved over 1 billion years, has given a human child the ability to instinctively recognize many things. Whereas the computer brain, which is less than 100 years old, is able to process a lot of mathematics, a lot of data, almost overnight if you apply the correct programming and develop the correct processing for the computer to understand what the challenge is and what the problem is and what the output should be. It can learn and give you output almost overnight. So mathematics is very easy for the computer, for the computing brain. However, the tasks with a child does, a 1-year-old child does, those tasks are mighty difficult for the computer brain or for the computing system. And that in essence, that conflict, the fact that the computers can beat human brains at games like chess and Go, whereas they cannot beat human child at recognizing faces or recognizing languages or recognizing handwriting, for example, that is a paradox. And that paradox is called as Moravic's paradox, Moravix, in his paper in 1980, along with his colleague Moravik et al., coined the term Moravix paradox. And Moravix paradox illustrates the inability of the computer to do some things that the child does, whereas to do exceptionally well when it comes to very high-end mathematical computations, which a human child, of course, cannot do. It takes many years of skill to become a mathematician, and that is called as Moravix paradox. So, this is one paradox. Now, before we delve into the others, where exactly are we today in 2021 with regards the evolution of artificial intelligence in the real world? Well, artificial intelligence is an ocean, just like human intelligence. And just like we haven't figured out all aspects and factors and underlying essence of human intelligence, we haven't figured out all applications of artificial intelligence. Because artificial intelligence is essentially depending on human intelligence for its growth. Therefore, today what we have is only a small branch of AI called as adaptive machine learning, which has done phenomenally well in solving certain problems in order to automate certain tasks which otherwise would have been extremely laborious for human beings to continue doing in the age of computers. So what we have today is adaptive machine learning, and adaptive machine learning is allowing us to use image classification and give a benefit known as facial recognition. Adaptive machine learning is allowing us to improve natural language processing, and therefore you have Alexa, you have a Google Assistant, and you have Apple Siri, so on and so forth. And adaptive machine learning is what is allowing us to get into a very complex image recognition processing architecture called convolutional neural networks or CNN, which is what is used in autonomous vehicles to recognize and identify objects in the field of view and then decide whether the autonomous car or the self-driving car needs to brake, decelerate, or turn left or turn right. So providing the autonomous vehicle with image recognition capability. And image recognition capability has multiple use cases in the real world. So that is where we are. We are just in the tip of adaptive machine learning. And the second cool thing is that the pilot projects in adaptive machine learning are all cool. Many applications in many verticals are extremely attractive, but only in the pilot project stage. Commercializing them at scale is a completely different story. That is where the world is today with regards artificial intelligence. A long way to go, but there has been an extremely good start in the 21st century and is only getting further accelerated. And by 2030, it's predicted that 500 billion, that means 500 billion devices will be connected to the internet platforms of the world. And this means all of this data which is coming from the smart machines will allow the cloud platforms to become more and more intelligent because of the data value chain that we just described and the AI agents within the platforms, making the platforms extremely intelligent. And at the same time, the devices at the edge becoming more and more intelligent because the embedded systems within these smart devices are also processing all of this information, and they will become more and more independent and interdependent with each other, with peer-to-peer communication systems. So that is a view from where we are today, 2021. Now let's go back to the paradoxes discussion. So we just discussed about Moravic's paradox. There's also a paradox in statistics called the Simpsons paradox, which of course will affect, because we're dealing with a lot of data, will also become a paradox within the AI world of data processing. And Simpsons paradox, for example, let's take Titanic. If you tabulate Titanic's survival rate results, and if you look at two aspects of the data in a table, first is the first row, let's say, is third class passengers, and the next row is all the crew who were there on board. And if you measure the survival rate of third class passengers as against the crew members on Titanic, you will see that the survival rate of the third class passengers was slightly higher. Now, this conclusion statistically is only a partial conclusion, because now if you further classify this data and introduce the element of gender, where you compare not just third class passengers and crew members, but classify this as qualify this as men and women, then the result is completely different, because women seem to have had a higher survival rate. Therefore, in the earlier data set, the aspect which was missing for computation was gender. So this is called as the Simpsons paradox, and this Simpsons paradox also occurs in artificial intelligence processing systems, because whatever data set has been given, there are always variations which come about in the final output depending on how you're tabulating the data set, one of the key factors, and how these data sets are being processed. So the outcomes can be varied. The third paradox is called the decision-making paradox. And the decision-making paradox is because, or what is the decision-making paradox? So, given a particular data set for solving a particular problem, there is always the possibility that you would get more than one outcome. And if you get more than one outcome, then as a human researcher, you have to decide which one you will have to go with. What it means is you are now left with the paradox of making the decision yourself while you're designing an AI system which is supposed to make that decision on your behalf. And that is called as a decision-making paradox. Now, this throws up two things to discuss. One is what is called as the learning bias. That means what is the data set that we are choosing and what are the parameters we are setting for the AI system to learn. Now, what the AI system will learn and the parameters that is being set as a framework will determine what the output will be. Therefore, if the data set is not diverse, if the data set is not validated, then the output is bound to be having a very strong bias because of the source of the data set. So that is called the learning bias. And then transparency. Today in the world, many AI systems, because of the nature of AI and the hype of AI and the investment that goes into AI, are proprietary. Not everybody discloses what is the algorithms or the systems and processes they are using in order to come up with the AI-based results that they want to commercialize. Therefore, there is a lack of transparency. And this lack of transparency poses a potential challenge and also a risk when it comes to sensitive data. So, this is a huge topic that needs a lot of deliberation, and not every government around the world has clear-cut guidelines on how this is going to be tackled. Nevertheless, it's an important point in the progress of artificial intelligence. The Next paradox is called the AI effect, artificial intelligence effect. And what this paradox essentially is saying is that AI over a period of time will no longer be intelligent. That means as the output of AI becomes commoditized and the use case becomes completely adopted by the human population, it will no longer be regarded as an intelligent feature. And that is called as the AI effect. It's a contradiction because when we started the AI project, it was a very attractive feature, and therefore we invested and started and implemented the AI feature, and therefore there was a benefit to all the users, and the users kept on using it. It became so mundane that it's no longer intelligent or considered intelligent by the human operators. Therefore AI loses its charm, or that particular feature or that particular use case loses its charm. So that is called as the AI effect paradox. And the last one here is called the AI paradox. And the AI paradox is essentially that artificial intelligent robotics that is coming into the world will actually allow human beings to be more human. I repeat, AI robots will humanize human endeavor. So today, people are involved in doing a lot of laborious tasks, a lot of manual work, a lot of work that involves putting human beings at risk. Tomorrow's android, humanoid robots will do those jobs which are high risk and laborious, thereby allowing human populations and human talent and human capital to be deployed into more creative tasks, into endeavors which are a lot more value added. So robots will allow our human beings, will allow us to be more human in our work life as well as in our personal life. So these are the paradoxes as we see today. And before we close, what are the goals of artificial intelligence? So goals are seeing, example, facial recognition and beyond, smell, the ability to detect odors, machines that can detect odors and therefore use cases that come from odors. And then natural language processing, speaking, reading, natural language processing, everything to do with voice. This will allow us to abstract language into computing platforms of the world. Therefore, by speaking and interacting using natural voice, we will be able to get more benefits from the computing platforms of the world. This will be powered by AI, and physical work will be aided through the inclusion of accessories and robots which help human beings to do physical work much more efficiently and make sure that injury cost to human beings is lowered and completely eliminated. In other words, artificial intelligence mimics human intelligence. It mimics what nature does so beautifully over billions of years. Nature solves continuously for complexity and comes up with solutions which are sustainable. AI is on that path. I hope you enjoyed today's presentation and you learned something from it. Thank you.